Hello, my viewers out there. It is just a continuation from where we ended. We are still looking at sound wave in science paper one, particularly physics. So these are now waves that have been illustrated. We are starting with the low pitched sound. Low pitched sound as the low frequency. Okay. So this is low frequency. This is an indication of low frequency. Okay. That's how it moves. Then from there, down here, we have the high pitched sound. It has a high frequency. So now what determines frequency when you look at the diagram that we have? So just the space. So if the space between them is big, that is low frequency. Then when they are tight, they are close to each other, that is high frequency. Okay, that's what it means. So when the frequency is low, the pitch sound also becomes low. When the frequency is high, the pitch sound also becomes what? High. Okay. Then this is about pitch sound. So let us come this side. This is just the demarcation that I actually put. Okay, that is the separating the pitch sound and the loudness of sound. So here we have soft sound, which has a low amplitude. To those of you who have been following me, I talked about this, about the pitch sound and the loudness of sound. So loudness of sound depends on the amplitude. So when the amplitude is low, the loudness of sound becomes what? Low as well. Okay, so when you look at this amplitude, we are talking about actually the distance from here up to there, that is amplitude. So this, when you look at them, they are very low, and the loudness of sound is also soft. Okay, then down here we have the high amplitude. So when the amplitude is high, the sound also becomes louder. Okay, then this side we have the normal sound. This is now normal. Okay, then getting back to pitch sound, also we have normal sound here. Okay, you have seen the way the waves are looking. Okay, so that is what I wanted to illustrate dramatically. So now we can quickly go to echo sound now. Okay, an echo is produced when a sound wave is reflected from the surface. Okay, so when the sound wave is reflected from the surface, there is an echo. So for example, if I happen to close where I am right now in this class, I close all the windows and the like. So once I make a sound, that sound won't go out because it has found the opaque material where sound cannot penetrate, or sound cannot go through to the other side. So instead, sound will bounce back, that is reflecting. So when the sound bounces back, I will again hear another sound, which is called an echo. Okay, so that is all about echo. So it is heard separate from the original sound in the sound source. Okay, is closer to the observer than the reflecting surface. So that one heard, it is actually heard separate from the original sound. The sound that I've made, the way it is going to sound, it's different from the echo. The echo will again be heard later on. Okay, why? Because the sound will go, then when it goes, it will actually reach to a certain surface where it is not going to continue its movement. It will again bounce. Okay, so again after it has bounced, then I'll be able to do what? To hear that same sound. So that is echo. That's what they're trying to say. Okay, so now apart from echo sound, as we are finalizing our main topic, sound wave, we can also look at ultrasound. What is it? So ultrasound, this is the sound with a frequency of more than 20 kilohertz, which is 20,000 hertz. Remember, we were talking about the normal sound, which actually ranges in terms of pitch sound. It actually ranges from 20 hertz to 20,000 hertz. Now, when we talk of ultrasound, that is beyond 20,000 Hz. And in terms of pitch sound, when the sound goes beyond 20,000 Hz or 20 kilohertz, the sound will not be heard. Okay, that's what we learned in our previous lesson. So now, this is the one that we are talking about, which is going beyond 20,000 Hz. And this particular sound is called ultrasound. Okay, so the human ear cannot hear ultrasounds. So ultrasound is not heard by a normal human ear. Okay, why? Because it has gone beyond the maximum. Okay, so now let us look at the application of ultrasound. So ultrasound is used in so many ways. So now let us look at some of the ways in which ultrasound is being used. One, prenatal scan to check the development of the baby in the womb. Okay, so it is ultrasound that is being used. Okay, sometimes in form of a solution. So that sound is used to check inside the womb, okay, the development of the what? The baby. Then two, it is also used in ships to find the depth of the seabed. Okay, seabed. So meaning in the ship, you know, that one sails on the river. So inside there, you can use ultrasound to check the depth of the what? The seabed. Then three, it is also used to check for cracks in small pipes that are too small for naked eyes to see. So ultrasound is also used to check for the what? For the cracks in small pipes that cannot be seen with our naked eyes. Okay, so these three are ones of what? Application of ultrasound in this particular lesson. So thank you so very much for your attention. And actually this marks the end of our main topic, which is sound wave. And I'm very pretty sure that you have learned that which you are supposed to know as a candidate. Remember, I'm here to give you the skills as well as knowledge on how to go about examination-oriented questions. So this is exactly the way you are supposed to answer in case you are given questions based on what you have looked at today. See you in the next class. But don't forget to subscribe to my YouTube channel, Pedagogy Learning with Mr. A+ Zambia. Thank you.